All right, ladies, in this video, we're going to go through the theory for 6E, negative indices. So when we're working with indices, we don't tend to leave power or the index in negative form. So you need to be able to transfer from a negative power into a positive power. So basically, if we had a to the power of negative m, we rewrite that as 1 over a to the power of positive m. Okay, so we basically change that negative and make it a fraction or a unit fraction 1 over. If it's a to the power of m and we want to put it into a negative power, we just do the same thing, but 1 over, now it's a to the power of negative m. So you need to know these two, okay, and how they relate to each other. And obviously, this 1 over a to the negative m, if you see that, you would rewrite it as a to the power of m. So a raised to the power negative m is equal to the reciprocal of a raised to the power of m. So the reciprocal just means you flip it, basically. All right, so I thought I'd add the building understanding thing in so you can see how negative indices actually work. So we don't tend to go through the building understanding, but they are pretty good. But this one here I thought will help explain, well, why does a negative index become a fraction, basically. All right, so let's have a look at, so I'm going to just look at this number 2, so state the missing numbers in these patterns. So 3 to the power of 4 is 81. So 3 times 3 times 3 times 3. 3 to the power of 3 is 27. So you can see our powers are going down. But if you wanted to fill this in, you could obviously start with 3 to the power of 0. Whoops, accidentally pressed the screen. Which we know any number to the power of 0 would give us 1. 3 to the power of 1 is 3. So basically, if we're going in the left direction, we're multiplying by 3 each time. So if our powers are increasing, we're going up by a factor of 3. So 3 squared is 9. But the little hint down here, if we were going in the right direction, we're dividing by 3. So 81 divided by 3 is 27, divided by 3 is 9, divided by 3 is 3, 3 divided by 3 is 1. Then 1 divided by 3 gives you a third, okay? So remember that is 3 to the power of negative 1 is the same as 1 over 3 to the power of positive 1. Then if we divide that by 3 again, we get 1/9, and you can write that in index form as 1 over 3 squared, okay, because 9 is 3 squared. And then we can divide that 9 by 3 again to get 27. So 1/9 divided by 3 gives you 1 over 27. And if we were to write that in index form, it would be 1 over 3 to the power of 3. Sorry, that's a bit small. Hopefully you can read that there. Okay, so that's just showing you how it works. We can do the same here for base 10. So again, you can start, if you like, here, or you can start at 0, make it easier for you. But basically, if you're working from left to right, we're going to be dividing by 10. So basically dropping a 0 each time. And a little trick, if you weren't aware, if you got 10 to the power of a number, whatever that power is the number of zeros you have. So you can see here we've got 10,000, but it's just the number 1 followed by 4 zeros. So 10 to the power of 3 is the number 1 followed by 3 zeros, so 1,000. 10 to the power of 2 is 2 zeros, so 10 squared is 100. 10 to the power of 1 is 10. 10 to the power of 0 is 1. Okay, so again, the powers tell us how many zeros we have. So 1, 0, 0 zeros. And then 10 to the power of 1 is going to be 1/10. Okay, so we're now dividing by 10 each time. 1 over 100, or if you wanted to write that in index form, it's 1 over 10 squared. And then we've got 1 over 1,000, which in index form is 1 over 10 cubed. Okay, so let's do some questions together. I might get rid of that just so we've got the space on the page. Okay, so question 1, let's start off with a nice easy one. Okay, because fractional indices can be quite difficult. All right, so if there was a coefficient here, we'd have to deal with that, but there isn't. So it's just going to be 1 over x, and we change this negative power into a positive. So it's just 1 over x to the power of 5. Let's have a look at question B, part I. So we've got 2a negative 3b to the power of 2. So the only thing that's taken to the negative 3 is this a. So in your fraction, everything else stays on top. So the 2, the b squared stay on the numerator, and just that a goes on the denominator. So it's a to the power of 3. If that was a bit hard to do in one go, you can rewrite this as 2a becomes 1 over a cubed, and then we've got b squared. If you wanted to make them all fractions, you can just make that 2 and the b squared all over 1. I don't know why I'm writing on an angle, girls, sorry. So when we're dealing with fractions, when we're multiplying, all your numerators are multiplied together. So 2 times 1 times b squared gives you 2b squared. And then 1 times a cubed times 1 gives you a cubed. Okay, so either way is fine. All right, let's have a look at question 2 now. Let's do some harder ones. I'm going to do m. 2a to the negative 3, b to the negative 1. So just like we did before, you can either do it all in one go. So anything that doesn't have a negative power stays on your numerator, and the others get taken to the denominator with a positive power. Now we don't tend to write b to the power of 1, so you can just rewrite that as just b. Now before, remember I showed you there were 2 ways, so if you'd rather write these all as fractions first and then do it, so a to the negative 3 becomes 1 over a cubed, and b to the negative 1 becomes 1 over b. You don't need to put the 1 in, and the 2 is just over 1. So multiply all your numerators. So 2 times 1 times 1 gives you 2. And then 1 times a cubed times b is a cubed b. All right, let's have a look at, maybe we'll do p, 2p, 9 to the negative 1, m to the negative 3, n to the negative 5. Now, we have everything to a negative power, so that means on our numerator we're just going to have the number 1, because there is a number 1 here. It's a 1 times, we don't usually write that, but the 1 stays there, and everything else goes on the denominator. So 9 to the negative 1, so the 9 goes on the denominator. The m to the negative 3 becomes m to the positive 3, and then n to the positive 5. Again, if you wanted to rewrite these all as fractions first, this line is separating. I hope you don't think that's a big fraction. That's just to separate. So 9 to the power of negative 1 is 1 over 9. Then m to the negative 3 is 1 over m cubed. And then n to the power of negative 5 is 1 over n to the positive 5. And then let's multiply everything together. So 1 times 1 times 1 gives you 1. And then multiplying all the denominators gives you that. Okay, so the first way you can see is obviously quicker. If you need, if you need to do the fractions first to kind of develop your understanding of what we're doing, then do it that way. Okay, question 3. Let's just get rid of all that first. All right, so let's do the easy one. Just getting my grip okay on my pen. 1 over y to the negative 1. So just going up here to show you your key ideas. So we're now converting, so this second one, okay, so we've basically got 1 over, now that base is y and the value of m is 1. So sometimes it's easier to refer back to your rules if you need to, but we can just write this as y. And that's basically all it is. You can write y to the power of 1, okay, but it's just y, Okay, so that -1 means that that y flips, okay? So it becomes y to the +1 over 1, which is just y. Okay, now maybe we should do one with a few numbers, so that might be a bit too confusing with everything being 1. All right, let's do E. So we've got 7. Oh, I've got a 1 again. Oh, we'll just do it anyway. Q to the -1. I was trying to choose something that didn't have a 1. So the 7, you don't have to change that because it doesn't have a power, or its power is 1. It's already a positive power. So the 7 can stay on the numerator, and that Q comes up to the numerator with a positive power, and you can write it over 1 if you like, but we tend to just write it as 7Q. Okay, let's have a look at, I think, let's do F. These are probably some of the harder questions in this chapter. So not just this section, but this chapter. So the 3 stays on the numerator, and the T to the -2 comes up onto the numerator from the denominator to the numerator as a positive. You can write the 1 there, but we tend to not write things as divided by a -1. Sorry, I'm not talking properly. Divided by 1. Okay. I've done quite a few videos in a row, girls, and I feel like maybe I should stop soon. Okay, let's try M. Okay, so the numerator, we keep as -3. The denominator, that 7 isn't taken to a negative power, so we can just leave that 7 there, and that y can come up on the numerator to the +4. And we don't need to simplify it any further. The -3 over 7 can't be simplified, so we just leave it like that. Okay, let's do P, so I can see a negative. I'm sitting on, so girls, I'm in the grade 1 classroom at the moment, and I couldn't sit at the tables because the tables are obviously lower and the chairs are smaller and I'm huge, but I'm sitting on a really hard chair. It's quite uncomfortable as well. Okay, so remember back to our previous index laws. So this 2 applies to this negative, and I'm going to put it in brackets just so we remember to deal with that negative sign. Okay, the 5 isn't taken to the power of anything, so that can stay on the denominator. The T being a negative power can come up on the numerator. So -3 squared, when you've got a negative base to an even power, it becomes a positive number. So -3 times -3 gives you +9. Then we've got U2 T2 over 5, and we'll just leave it like that. We don't need to put it into a mixed number. I can just leave it as an improper fraction. All right, let's get rid of that so we can do question 4. Express each of the following using positive indices. Okay, let's start with D. M -1 over N to the -1. Okay, so basically if we want positive indices, the M has to go on flip over, so it comes now on the denominator, and the N comes on the numerator. So you're just flipping them basically. Let's find a harder one to do. Let's do F. So 3 to the -2 over 4 to the -3, the same thing. So the 3 now goes on the denominator and the 4 comes up on the numerator. You can, doesn't say to leave it in index form, so we can simplify. So 4 cubed, 4 times 4 is 16 times 4 again gives you 64. 3 squared is 9, and I don't think we can simplify that any further, but I'm just trying to think quickly in my head. No. Okay, so we'll just leave it as 64 over 9. You don't need to write things as decimals. When you're dealing with harder maths, I find leaving it in fractions is easier anyway. All right, let's do some questions from 5. Let's do 5E. 5a squared c negative 4 over 6b negative 2d. Okay, so this is where you got to go through each number or each letter and decide whether it stays on the numerator or goes to the denominator and vice versa. So start your fraction just by putting in your vinculum, the line that separates your numerator and your denominator, and just go through each thing separately. So this 5 stays on our numerator, the a squared stays on our numerator. Now the c, because it's to the negative 4, comes down as positive 4, so c to the power of 4, okay? And then let's deal with our denominator. Now, because we're multiplying, it doesn't matter your order. The 6 stays there. I'm going to put the 6 here at the start, but if I put the 6 there, it's not going to make any difference. The b to the negative 2 now comes up to the numerator as b to the positive 2, and the d stays on the numerator. Now, I don't need to simplify that any further. If I had to do some cancelling out, you could, and maybe there'll be some questions later in the chapter that requires you to do that, but that is in its simplest form. Let's have a look now at G. So we've got 4t to the negative 1, u to the negative 2, over 3 to the negative 1, v2, w negative 6. So just like we did before, draw your vinculum. 4 stays on the numerator. The t to the negative 1, so it comes down onto the denominator as t to the power of 1. You can write t to the power of 1 if you like. And then the u also goes down the bottom, say tu. Okay, so now we've dealt with everything in the numerator. Now we deal with the denominator. So 3 to the negative 1, because it's a negative power, we now switch. Now I'm going to put a multiply sign in there so I don't see it as 43. It's 4 times 3. The v squared stays on the bottom, and then the w comes up as w to the power of 6. So let's just tidy things up. So 4 times 3 gives you 12. So 12w6 on your numerator. I think that's in alphabetical order. W, X, T. Okay, I think. Could you hear me singing the alphabet in my head? There we go. So TUV squared. All right, girls. See ya.